You know, there are these invisible forces all around us, shaping our world in ways we don't even notice. And there's one in particular, a really mysterious power that's working silently, right now, all around us.
I mean, have you ever felt it? That strange pull? Maybe you're just playing with magnets on the fridge and you feel that weird push or pull from something that, well, it isn't even touching. So what is that?
Well, that force, that's magnetism, and it is a huge deal. We're talking about something responsible for everything from a simple compass pointing north all the way up to the giant invisible shield that protects our entire planet from the sun. It's wild. Okay, let's really get into it.
So, where do we even begin with a force this big? Well, to really get it, we kind of have to go way back to when we first stumbled upon it.
It all apparently started around 800 BC. The legend is there was a shepherd, his name was Magnes, and he noticed something weird. The iron nails in his shoes and the metal tip of his staff, they kept getting stuck to this one particular rock. And that rock, which we now call magnetite, was basically humanity's first introduction to a natural magnet.
And right away, this one discovery showed us something fundamental. It's like the world is split in two when it comes to magnetism. You've got your magnetic materials, stuff like iron, nickel, cobalt, that are attracted to magnets. And then you've got, well, pretty much everything else. Wood, plastic, glass, even copper. They just don't seem to care about it at all.
So naturally, once we started finding more of these strange rocks, we began to study them. And we figured out pretty fast that they all seem to play by a very specific set of rules. Yeah, there are basically 4 key properties of any magnet. Number 1, they attract magnetic materials, like iron. That's the obvious one. 2, and this is cool, if you let one hang freely, it will always point north-south. That's the entire secret behind a compass, right there. 3, their ends, what we call poles, have a very simple but strict rule about how they interact. And 4, their poles always come in pairs. You can't have one without the other.
And here's a little bit of trivia for you, something that's actually kind of surprising. We always talk about the ends of a magnet, right? But the poles, the points where the magnetic force is strongest, they're not exactly at the very tip. They're actually located just a little bit inside the magnet.
And when we talk about how those poles interact, it all comes down to one golden rule that you've probably heard before. Opposites attract. Likes repel. That's it. A North Pole is always drawn to his South Pole. But if you bring it near another North Pole, it's going to push it away. Every time.
And you can see that principle in action right here. See how the unlike poles, north and south, just pull right together? But then, look what happens when you try to push 2 of the same poles together. You can literally feel that invisible force pushing them apart. It's that classic repulsion.
And that leads us right back to that last rule we mentioned. You can't have one pole without the other. They always exist in pairs. You can't just say, break off the North Pole. It doesn't work like that. If you actually snap a magnet in half, you don't get a separate north piece and a south piece. Nope. You just get 2 smaller magnets, and each one has its own north and south pole. It's fascinating.
Okay, so we've got the basic rules down for a little bar magnet. Now let's blow this up, way up. Let's talk about how these same rules apply to our entire planet.
So every single magnet, doesn't matter how big or small, is surrounded by this invisible bubble of force. This space around it where its power can be felt, that's what we call a magnetic field.
Now, obviously, you can't see a magnetic field with your own eyes, but we can make it visible. You've probably seen this experiment. If you sprinkle iron filings around a magnet, they don't just land randomly. They trace out these beautiful, elegant lines, revealing the hidden shape of the force as it flows from the North Pole out and around to the South Pole.
And here's where it gets truly mind-bending. Our entire planet acts like a giant magnet, a colossal one. It generates its own massive magnetic field that envelops all of us and stretches way out into space. That compass needle? That's what it's aligning with, Earth's own magnetic field.
But, and this is the really wild part, even though our planet acts like a huge magnet, there isn't some giant bar magnet buried down in the center of the Earth. So where does the field come from? Well, it's actually generated by the churning of molten iron in our planet's outer core. It's a dynamic, flowing process, like a giant natural dynamo.
Okay, so we figured out what this natural force is. But of course we didn't just stop there. The next step for humanity was to figure out how to control it, how to make it, how to break it, how to turn it on and off whenever we want it. And we did learn how to make our own artificial magnets. They basically come in 2 flavors. You've got temporary magnets, usually made from soft iron, that you can, well, turn on and off. Then you have permanent magnets, made from things like steel, that stay magnetic for a very long time. And being able to choose between always-on and on-demand magnetism, that's a real game changer.
And one of the most powerful ways we create those temporary ones is with electricity. It's pretty simple, really. You just coil a wire around an iron core, and then you pass an electric current through that wire. Boom, you've got an electromagnet. And the best part is you can turn it on or off just by flipping a switch. Total control.
So if we can make them, it makes sense we can also break them, right? The whole secret to a magnet's power is that all its little atomic parts are lined up perfectly. So if you do anything to mess up that perfect alignment, you destroy the magnetism. We're talking about rough handling, like dropping it a bunch or even hammering it. Heating it up really hot works too. You can even use an alternating electric current to scramble everything up and turn that magnet back into just a regular old piece of metal.
And this is where it all gets really incredible. Because this invisible force, it's not just some neat science trick. It is woven into the absolute fabric of our modern world. I mean, just think about it. It's in the speakers and headphones you're using. It's in the electric motors that power, well, everything. It's how your computer hard drive stores data. It's in those massive cranes that lift scrap metal. It's even at the heart of medical scanners like MRIs. It is literally everywhere.
So when you step back, it's an amazing journey, isn't it? We went from a shepherd finding a weird rock to literally commanding this invisible force to power our technology and even protect our planet. It really makes you wonder, now that we understand the rules so well, what are we going to make it do next?